Hello, welcome back to the channel, and today is a slightly different video. So when I started doing this series about my solar journey, I also started a second series called the Science of Solar Panels, Batteries and Everything Else Energy. Today I'm basically going to combine the two ideas together. So this is not only going to be talking about my solar journey and some observations I have and thinking about where solar is going to go in the future. It's also going to be looking at a little bit of the science, or at least the history of the science of solar panels and technology. So I'm going to start off with this video by talking about Gordon Moore. So Gordon Moore was a chemist and engineer and entrepreneur, and he was one of the co-founders of Intel. And he made a prediction in the 1950s which became known as Moore's Law. So if you are done any form of electrical engineering or computer science, or in my case physics and nanotechnology is sort of all based around, or computing nanotechnology is all based around Moore's Law, or I say it's all based, it's a fundamental part of any lecture series you do. Moore's Law was, as I say, his prediction that every 18 months to 2 years that the number of transistors you can fit on a circuit in a chip, in an integrated circuit, will double. And that meant that computing power would double every 18 months to 2 years. He also has a slightly different version of the law which talks about the cost therefore halving every 2 years as well for one of those chips. So it's not really a law of physics or engineering. As I say, it's more of a prediction or an observation. It has now got to a point whether it's actually predicting the trend, or whether companies or research is actually aiming to keep Moore's Law going. Because every sort of few years now you'll always get an article in scientific papers or journals or magazines saying that Moore's Law is coming to the end, and then within a few months a new piece of research has come out to produce more transistors in the same amount of space, and therefore continuing Moore's Law. So that was, I say, Moore's Law, but the question I have that I've been thinking about is, does Moore's Law apply to batteries and solar panels? So I did a quick Google search, and I've sort of combined this with my own sort of general thinking about this, and in short the answer is no. The full idea of Moore's Law, of it doubling every couple of years or every time period, doesn't exist. However, there are some similarities we can draw. So I first of all had a look at some solar panel prices over the past few years, and so the best way to measure the price of a solar panel is to measure it per watt. So over the past sort of 12 years or so, the price per watt of a solar panel has decreased. So this is in US dollars. So back in 2012, the price of a PV panel was about just over $1. It was $1.03 a watt. In 2021, that had dropped to 55 cents a watt. So there's a number of reasons for that. It's one, that there is more supply, there's more people making them, therefore competition in the marketplace is driving down those prices. They're becoming more efficient to make, they're actually becoming slightly bigger, and you can fit. And you've moved from polycrystalline panels to monocrystalline, which is just more efficient, and therefore you can get more watts in the same area. So the price of the actual panels has dropped. The price of fitting has dropped as well, from $6.2 per watt in 2012 down to $3.8 per watt. This is from a website called cladco.co.uk, where they've done a bit of analysis on this. So solar panels have definitely come in cheaper. The problem we've got though is they don't really follow the actual efficiency of solar panels hasn't really increased. So if you look at the Wikipedia page, which is solar cell efficiency, you'll see a diagram there which I'm looking at on my screen now, and it's basically got the efficiency of all the different types of solar panels, from things like perovskite solar panels or solar cells, single crystal silicon ones, multi-crystal silicon ones. So it's quite a difficult graph to actually follow, but using my own knowledge I know that silicon solar cells have been sort of stuck in the 20 to 30% efficiency range for a good number of years now. Perovskite solar cells have been getting more efficient, so in the early 2010s when the research started on that, you had a very steep increase in efficiency from about the 14% up to the mid-20s, but that's now sort of arced off at the top, so it's not following the Moore's law. I should point out that Moore's law, for the fact that it's doubling every time period, is actually an exponential style graph. None of the graphs of solar panel efficiency looks anything like that, and the price one doesn't look like that either. There are some solar panels that are getting more efficient, so this is a 4-junction concentrator multi-junction cell. They are of about 2023. A group has, so this graph actually breaks down what group has looked at it. So this is the FHG-ISE 4J665X point on the graph, is stating a efficiency of solar panels of 47.6%. Haven't gone through and looked at all these individual bits of research. I should point out that sometimes the efficiency is just measured off a very small cell, not the type of cells that you put on the roof, and when you scale them up, the efficiency does drop. So that's one of the problems with the solar panels, and that's actually one of the reasons why it's not following Moore's law, is that you happen to invent new technology, and every time you create the new technology, a new problem starts coming around. So this what happened with dye sensitized solar cell, is that they looked like they were going to be very efficient, however they lasted for about 6 months before breaking. So that's been the problem with Moore's law in photovoltaics. So the other thing that people are having a lot of at the moment is batteries. And battery efficiency. So I found this on a Quora website, and it says, the title of this article, "Is it true that battery energy density improves 5 to 8%?" And in this article, they've actually done a comparison to Moore's law. So they've actually put on a graph what Moore's law would have looked like. So with batteries, the general push for these has been energy density. How much energy can you store per kilogram of battery medium? This is actually starting to follow an upwards trend, which is getting steeper. But it's relying basically on new chemistries to be introduced for doing this. So we started off from this graph with nickel cadmium, which follows a straight line graph, coming up to about just under 100 watts per kilogram by the mid-2010s. You had nickel MH, I'm not sure what the M stands for there, I'm assuming some sort of nickel battery. That has gone just, is predicted to get over 100 watts per, or watt hours per kilogram in the mid-2010s. But that technology started in the mid-80s. You've got here a lithium, nickel, manganese, cobalt oxide battery on this graph, which seems to be much steeper, starting at over 200 watt hours per kilogram in the around 2010, and that's following a steeper trend. So if you take all the different trends and plotted them out there, you would actually get a curve that goes up. So hopefully I'll put up these diagrams on the as you're watching this, so you can see what I mean. But it's not a true Moore's law relationship. So the thing with batteries as well is that people are trying to move away from less controversial metals. So things like cobalt has been worked out of many battery systems. Lithium is another one that they're trying to work away from and replace with things like sodium, which is far more abundant, far cheaper. So the price of batteries should be coming down. So I'm just going to finish this video with saying, just because technology is moving on doesn't mean the prices are going to come down. There is more place in the marketplace, there's probably more research being done in this field. However, economics also has a massive play. With the current energy prices over the past few years, the price of solar panels and battery installations shot up massively just because of demand and supply and economic side of things. So for the system I had installed last year, which cost about 8,500, to get a cylinder system now costs 9,500, and that's an inflationary effect as well. So things are moving, but this might be just a short-term blip on that graph, but sort of more data is required to see if there is going to be equivalent of Moore's law. My suspicion is that there probably won't be. It's not going to be exponential, but it should be fairly linear over time. Anyway, hope you found that video useful, just having a bit of a look about how scientists think and target improvements in battery and solar technology. And I'll see you in another video soon.